Hi guys, welcome back. This is Flip Geometry video number 18. And in this video we're going to look at the square pyramid. Alright, I created a square pyramid right here by, tracing a little template and cutting it out and putting it all together with a little bit of tape. Now it doesn't work perfectly, but in a perfect world, I would have all four of those sides. Of course, it's a square pyramid because there's a square base, and that's what you can see here. And then the four triangular sides come together in a perfect vertex at the top. So, let's take a look at the surface area of a square pyramid. Now, what I've done here is I've taken this and I've broken it out into its net. So essentially, I've taken those four sides, taken all the little bits of tape off, and folded them back out so that I can see it as this. Now, the square base, that square base has a little b right there. That's going to be this little b right here. Now, because it's a square, that means that every single side of that base is going to be b. So that's b, and that's b, and that's b, and that's b, just as it is there. So in terms of the base area of this square pyramid, we only have one base, and it's square. So this area here, as you can see, is this area right here. That's the base. So as far as our formula is concerned, the surface area is going to be equal to that area. Now it's b multiplied by b. Now, I know I always say don't put the dot there, so I'm going to take my own advice, and I'm going to indicate it as b multiplied by b, just like that, plus the area of the lateral sides, which we'll come back to in just a second. But what I want to show you here is we have b multiplied by b, which is, well, that's b multiplied by itself. So in other words, that's a situation where we can simply say b squared. Okay, so b times b squared for that area of the base of our square pyramid. Now, notice that we've got four sides to this pyramid, and all four are identical triangles in this case. Now, the distance from that vertex here down to the base, I'm indicating that distance there, from the vertex to the base. I'm not indicating the distance from the center of the base. So I'm not going to the center of the base. Essentially what I'm doing is going from this B up to the vertex. So that distance there would be the same as that distance. And that's going to be the same on all four of our sides. Now, this is a little bit different than some of our other calculations with triangles, because now we know that in terms of area of a triangle, we usually say that the area of a triangle is going to be this. Little b times little h divided by 2. However, a slight change here, because little h is not that. For this particular triangle it might be, but in terms of this square pyramid, it's kind of a unique distance from there to there, because it's not exactly straight up and down from the middle of that base. If you can imagine, it's on an angle. So if you can imagine this, it's the distance from there to this base, which is on an angle here. It's not straight up and down from the base. It's down to this side. We have a unique name for that. We're going to call it L, and the way I write it is kind of like that. So we're going to call it an L, just like that. So the formula changes here in terms of the area of the triangle, just a little bit. So it's still a little b, but instead of little h, we're now going to call it this. Little b times that little L divided by 2. So, how does that work? Well, in order to get the area of this, I simply follow that formula. And I have it 1, 2, 3, 4 times. So in terms of our formula overall here, we have 4 of those triangles. So we need to use this formula 4 times. So I simply say base times that little l. And that little l, we're going to give a name called the slant height. Okay? Little l, we'll call it the slant height because it's on a slant, it's on an angle, right? It's that angle from the base up to the vertex, like that. It's not the straight from the center of our base up to the vertex. It's on an angle. So we call it the slant height. So we're using this formula. We're now here. We've got 4 of those triangles that make up our square pyramid. So we're saying 4 base times the slant height divided by 2. Now you might say, wait a minute, I've got a 4 in the numerator and a 2 in the denominator. You can cancel that because if you divide both of these by 2, that becomes 1 and that becomes 2. Looks like I'm squaring it there when I'm really not. I'll make sure I'm not doing that. That became a 2 at that point. So what happens here is that I ended up with b squared plus 2, that was left over from here, times our little b times the slant height. So there we have it, the surface area of a square pyramid, this formula here.